today, I'm going to be introducing you to a completely new concept in programming that a lot of you probably haven't experienced yet. But just, could I just have a show of hands of who's actually heard of this and who knows about it? Okay. But I guess some of you may have just heard about this phrase before, you just don't know what it means. And we're just going to try to just take a look at what it actually is. But before we go on to that, object-oriented programming initially can seem quite daunting, quite intimidating and confusing. And that's why it's so important that if throughout this presentation, if you have any questions, put your hand up or just shout out your question, because we don't want you to be sitting there confused, not really understanding what's going on. But object-oriented programming is a completely new paradigm of programming. It's a completely new way of thinking about it. And what that really means is, so far, whether you've been aware of it or not, you've been doing something called procedural programming. And that's another type of programming. And what this is when you tell the computer literally step by step what to do. You give them a list of procedures or instructions of what to do. And an example of this is something like this. Can you guys read that? Or yeah. So this may seem familiar too. You get two inputs, name and age. If this, do that. Else, do that. Can anybody tell me if I put in the inputs Ojun and 17, what that's going to return for me?
Sorry, Ojun, you were too young for this movie.
Yeah, so that's exactly what's going to give. And it's just simple procedures, line by line, step by step. You're telling the computer what to do. And now, just to give a little snippet of object-oriented programming, don't be intimidated, but this is the kind of thing that you're going to be able to understand, hopefully, by the end of this presentation. And just a few things that I want you to notice for now are just taking a look around. It looks a little bit different. There's a lot of indentations here. You can see there's a thing called a class over there. We don't really know what that is yet. And some functions that are defined over here. And something that you might recognize here is we've got a bit of procedural programming here. If, else, which is what you're familiar with. And the reason that I put that in there was to show you guys that even though procedural programming and object-oriented are different paradigms in programming, they're not mutually exclusive. So you can use both of them in the same program. And most likely, if you do use object-oriented, you're probably going to use some procedural programming in there as well. And also, both this and the previous one are written in Python. So they're not exclusive to certain languages. Some languages don't support object-oriented, but in the case of Python, it supports both equally well. That's not a problem there. So, yes, a program is fundamentally made up of two things, data and actions. And in procedural programming, which is what you've been used to for now, there's a lot bigger focus on the actions. And it's about what the computer is doing with the data that you get. So if you go back to my program, you get the name and the age, and the program is really, the gut of the program is what it does with that. If this, do that, else, do that. And in object-oriented programming, the focus goes on to data. And this is hopefully a distinction that's going to become more clear to you as we dive deeper into it. But object-oriented programming is really about how we represent data, or how we modify data, how we visualize data, or how we display data. It's all to do with the data. And that's why you're going to have to use procedural programming alongside it to perform the actions that you want to do with the data. But that'll make a lot more sense soon. But before we go on to talking about the code and stuff, let me just start off really simple by throwing a question out there. Can anybody tell me what this is?
Chair.
Yes, it's a chair. It's going to get a little harder, guys. Question 2 is this.
Also chair.
Chair, good job. 3. Chair. 4. We've got 4 objects over here which are very different. They've all got their own characteristics. And we can just see that they're very different colors. One's got an armrest, some doesn't. This is made of wood, that's made of leather, whatever. But what's very interesting is that even though they're all so very different, we all sort of intuitively knew that these are all called chairs. And the Greek philosopher Plato thought about this very same question. You can search out Plato's chair on Google. There's a lot of interesting articles there. And that's what inspired him to create Plato's theory of forms. And this is going to seem a little bit irrelevant at the moment, but it all ties together, I promise. So according to Plato, there exists another world, not a physical world like ours, but a world full of ideas and concepts and forms. And he says that in this world, it contains perfect forms of every physical object on Earth. So what that means is, going back to these chairs, according to Plato, each of these 4 objects here are imperfect representations or imperfect instances of this perfect chair that exists in this world of forms. And in that perfect world, the reason that we know this belongs to that form is because they all share certain characteristics or attributes, such as maybe in the case of a chair having a backrest or an armrest or a surface to sit on, some sort of structure. So it's all these things that are defined by its perfect form. We can see through the instances on Earth. And that may not make a lot of sense at the moment, but hopefully as we keep going through it, it's going to make much more sense to you. And the reason that I even talked about this whole thing is because in essence, that's what object-oriented programming is. It's where we define a class, we give a template for what certain objects that belong to a class are. We give them certain attributes, and all objects that are part of this class, these instances of this class, share these attributes, much like this chair, or these chairs, with this perfect chair that Plato was talking about. So if we actually jump into some code, into some Python, we can see here defining a class is very, very simple. We just say class and then the name of the class. In this case, I want to write a program, let's say, that kind of gives a template for what a human is or what a person is. So the name of the class can be called person, simple as that, no worries here. Next, this may look a little bit scary to you. And in the beginning, I said that we have some functions in here, but actually, we got to look at terminology, because whenever, this is exactly the same as a function, but because it's inside a class, we have to call it a method. So it's exactly the same as a function, does exactly the same things, the syntax is the same, but we have to call it a method because it's inside a class. And now, this specific method has a special name, underscore underscore init underscore underscore. And this is a special type of function, a method. It's called a constructor, and it exists in every class that you make. And this specific method has to be called underscore underscore init underscore underscore. Then init means initializing your variables, or initializing the attributes of the specific class called person. So if you think about a person, there's a lot of variables about them, like hair color or eye color or whatever. But I just simplified it to name and age, because everybody has their own name, everybody has their own age. So now, if you take a look at this method more closely, we can see it has three parameters: self, name, and age. And the name and age over here can be named anything. We could have called them X and Y, or A and B, as long as we keep referring to them by their names. But this self has to be called self. And what the self means is it's referring to a specific instance or a specific object that belongs to this class person. So if we consider the people sitting here right now, we're all people, we're all persons, so we belong to a class called person. But we each have our own individual name and our own individual age. And these attributes are specific to every instance of this class. And that's why these are actually called instance attributes. They're specific to every single instance. And you may hear people talk about them as instance variables. That means exactly the same thing. You may even see instance properties, but those are actually slightly different, but I won't go into that for today. So as you can see here, the syntax for referring to a specific instance is the name of the instance. In this case, self is referring to the instance. But when I actually declare it, this will become much more clear, trust me. For now, and we're creating an instance attribute, we'll call it name, and we're going to pass the argument from when we declare it to add to the instance attribute, and the same for the age. And as I said, it'll become much clearer now when we actually see how it's declared. Yes?
You know when you do self.name?
Yeah.
Does it have to be name, or can it be anything?
Basically, this, I should have named it differently to make it less
Good
confusing.
question.
But the parameter, name and age, are referred to here. That's what it is. This can be named anything. They can both be named whatever you want, as long as these are the same, because that's what you're taking in as inputs. And this is the name of the instance attribute. You can name it whatever you want.
So then the self is like the name of the object, right?
Yeah,
so
all
it's
the
like saying
instance,
Ocean.name.
Yeah,
And
and
then
you
it
see
returns
that.
out your name.
Yeah. So you'll see like when you do Murtaza.name soon.
Yeah.
But for now, if you actually want to create an object at this point, the syntax goes like this. See the name of the instance. In this case, we're creating Murtaza, and he belongs to the class person. And something interesting is when we declare it, we're passing in two arguments. Yet there's three parameters for the init method. And the reason for that is, as I said, the self refers to the instance. And because we have Murtaza over here, Python knows we're creating Murtaza, so it knows self is referring to this instance, which is why we don't have to pass it over here. We only have to pass the name, which is Murtaza, as a string, and age, 16, as an integer. Yeah, and as Will smartly pointed out, if we want to refer to these individual instance attributes, we get to print murtaza.name, which will print the name associated with the object murtaza, and murtaza.age prints the age associated with the object murtaza. So if we run this program, what do you think it'll output? Murtaza 16, yes. And that's exactly what it does. So at this point, does anybody have any questions? Because we're going to go on to tackling this next. So we just need to make sure the foundations are there for now.
I think that's a really good question, because that's something that confused me as well. Yeah, but yeah.
I was thinking
You
about
explained that really well. No, you explained it well.
I was thinking about naming them differently, but it's kind of a convention just to do it like that, which is why I follow the convention. Yeah.
Isn't another bit of convention about the capitalizing of the new class?
Of the new class? I think it is.
Yeah, it's a strong convention to have the class name with a capital first.
Okay, cool, thanks.
Good question. Good answer. So we're gonna move on to talking about this now, and it does seem a little daunting. So for now, let's take a moment just to breathe. Yeah, we're all feeling calm, we're all happy. And just to give some context to this program, let me get rid of this mouse. Yeah. So let's imagine that we're a company, we're a firm, and we have a lot of employees working for us. And we wanted to create a program that stores all this information about every employee that we have. For example, we want to store their name, we want to store their gender, and we want to store their salary for every single employee at the firm. But also, we want to be able to calculate, or the program to be able to find out the total number of employees at our firm, the total number of males, the total number of females, and the mean salary for the whole class of employees, if you will. And we're just going to go through this line by line. So class, can you guys read that? Can the camera see that?
Yes, we can, Jun, yeah.
Yeah, class employee. As I said, that's how you define a class. It can be named anything, I decided to call it employee. It has a convention, capital E. Total number, and this, you may have been expecting to see the init method like we saw before. And there is a reason why we have this outside the init and why we have certain things defined inside the init. So as I said, when you run an init method, or when you create an object, the init method is called. And it asks for these, name, gender, and salary. And I told you guys that each of these attributes are specific to every individual instance. So these are called instance attributes. As I said, everybody has their own name, their own gender, and their own salary. But we can see some variables or attributes defined at the corner, which is outside the init function. There's no self attached to it. So this isn't talking about any specific instance. These are variables talking about the whole class as a whole. And that's why these are called class attributes as opposed to instance attributes. And they can be called class variables as well. Class properties are slightly different, but as I said, I'm not going into that for today. And the reason these guys are different is, as I said, it's about whether it's referring to a specific instance or the whole class as a whole. So if we're trying to find the mean salary, we're not talking about one person, we're talking about all the people combined. So now, and now we're going to have a bit of procedural programming, which you may be familiar with. We've got employee.totalNum here, and that plus equals just means you increase it by 1 if you're not familiar with that. And what we're doing here is, as I said, every time we create a new object, the init method is called. And if we want to keep count of the total number of employees, we want that to increase by 1 every time we create a new object. Hence, every time the init method is run, it's going to increase the total number of employees by 1. And notice how before, if we go back to Murtaza, we've got the name of the instance dot the name of the instance attribute. This time, we're referring to a class attribute. So it's a very similar thing. You have the name of the class here, followed by the name of the class attribute. And that's an important distinction to make. So, as I said, just increase the total number by 1 every time. Now, can someone tell me what this is doing? Or have a guess of what this is doing? Alex?
It's doing the exact same thing as the previous function, the employee.totalNum, except for the male and female ones.
What do you mean by exactly the same? So like explain it line by line.
Okay. If the gender of the employee is male, then the number of total male employees is increased by 1. If it's female, then the number of female employees will increase by 1.
Yeah, that's pretty solid. Yeah, good. So that's what it does. And just note here that males, not self.males, because this is referring to the whole class and the class attributes as opposed to any specific instance attribute. And the raise exception, you don't really need to know it. It just means it raises an error and it says it's not male or female. So that's that. And if we move on some more, it's just some math here, some arithmetic. If we want to find out the mean salary, we're just going to add on the salary of this new object to the total of whatever we have until now and divide it by the total number of employees to give us the mean.
Ocean, I have a question.
Yes.
So you know, because this is all in the init method, I've noticed that when you do if gender is equal to male, you don't have to do if self.gender is equal to male.
I guess you could, because you said that self.gender is gender here. So that would do the same thing. But in this case, if you do self.gender, it would be referring to the attribute of the instance. But in this case, we're just referring directly to what the user is passing as an argument. But we're making them equal anyway, so that would do the same thing. So yeah, there's just some things there to keep account of the statistics.
Could you just explain the else raise exception?
Raise exception. Yeah, it just basically, if it doesn't meet male or female, just to be politically correct, I put this in here. It just raises an exception. The program will tell you that this object or this person is not male or female. It's just as simple as that. Yeah.
If they don't put male, female in, will it still run the rest of the program, or will it?
I think it'll say there aren't enough arguments.
What do you mean? Like, because you know how if you do an if statement and you put like male and then else is without, and then they put something else in.
So if they put in like 5 as the
what would happen?
You should put validation checks.
And the whole thing will stop.
It stops.
Unless you handle the exception. Or
Yeah. And if you're a good programmer, you should put in validation checks to every single argument that you take in, just to make sure it's the format you wanted it. But I didn't do it because I'm a bad programmer. So if we move on, now we're making a new method. As I said, the init method has to be called __init__ because it's a special method called a constructor. But now, whatever we make now, for example, we want to display all the information that we have about a specific instance of the class employee. We can call it whatever we want. Either call it disemp or display employee information or whatever. It could be called whatever you want. But there are actually a few functions that aren't like special, like init. They don't have to be called init, but most programmers put them in when they make a class. And the display function is one of them, or display method is one of them. Two others are getters and setters. And I didn't actually implement them here. But what a getter does is it gets information from a specific object. So I could have def, like get salary, and then have self, and then get the salary of whatever, have it print out the salary of whatever object. A setter sets, or resets rather, one of the instance attributes. So I could have set salary, and that could be used to modify the salary of any object. Yes?
can I just add that that's usually not done in Python. So
Is
it's
it not?
in Java and C#. But yeah, it's good to include.
Okay.
Yeah, worth mentioning.
But for now, I'm going to display. So it's just quite straightforward. It takes in the argument self, because we need to know which instance we're talking about, and then prints out self.name, self.gender, self.salary, in this format over here. And now, if we're done with defining the class, we're back to the program. We're going to create an object, let's call it Ojin. Let's say it works for us. He's part of the class employee. As I said, we don't need to pass self separately because it knows I'm talking about Ojin. So I just need to pass the name, Ojin gender, male salary, 2000. And if we now do display Ojin.display employee, this is a new bit of syntax. We haven't actually seen how to call a method that we have. So in this case, we're actually calling this method display employee, and as I said, it takes in the argument self. So we need to tell him that we're talking about the instance called Ojin, which is why we do Ojin.display employee. It's exactly the same as if you want to call, let's say, an instance attribute, you do Ojin.salary, or if you want to do a class attribute, you would do employee.totalNum. For a method, you just do the name of the instance and then the method, assuming that the method requires the instance, of course. And can anybody guess what this is going to return to us?
Would it say name, Ojin, gender, male, salary, 2000?
Yes. There we go. And you have new lines in there just to get a new line. And before I congratulate you for making it through, anybody have any questions? Final opportunity to ask.
So is there any point at which you might do a method that doesn't have self in it?
doesn't have self.
Yes.
There are some things called class methods. If you want to like mess around with the class variables, I didn't go into that today. Murtaza, can you think of any other methods?
In this context.
In this, usually, so they're called static methods, which means that it doesn't matter which object is calling them.
Okay.
And they could be used for this employee thing. You could say, you could for some reason have a class method that says delete all females. And then that would affect the class variables because it doesn't matter which object called it.
So are static methods a type of class methods?
They're class methods, static methods, same thing.
Same thing. Oh, okay. Yeah.
Static.
But if can I give an example? And again, I genuinely don't know what. If I wanted that, you see the total number, the males, the females, the mean salary. Let's say I wanted to call a method on an instance that works with those.
Those can always be accessed from within the methods in the class.
But what if I didn't want to do it? Is there a way where I could just say, for example, oh yeah, but I see what you're saying, yeah, because you just press self in. But could I write, for example, a new method and call it get mean salary, and just call it def get mean? Don't pass anything, don't do salary, and because it's got nothing to do with its instance, it's a whole class, and then just put print mean salary.
You can't do that.
There's a separate syntax for
Because-
class methods.
Yeah, because in Python it's weird. You have to do static method, something called a decorator. But in some languages you might be able to create a method that doesn't take self, and then you can do it. But that's kind of an implementation detail. Like it depends on the language.
Oh, so. For me, that's just clear things that I've been looking at for cognizance are.
You know the display employee thing? You know how you did self.name and
Yeah.
that format? Would it still work if you did name, gender, and salary?
Name gen? No, because for this specific method, it's not taking in any arguments here. So there's no inputs at all. It only knows which instance I'm talking about. And because we've programmed in already the name, gender, and salary of this particular instance, we can reference the attributes of this instance, but because there's no arguments here, we can't actually refer to them.
I was going to ask exactly the same question. I really was.
But if you made it equal to it, wouldn't it be this?
Yeah, if you add the parameter for name, gender, and salary for the display employee, then you could refer to it there.
If you took these three lines
Yeah.
And then
and put them there in that method.
No, the other way around. If you flip them around.
What do you mean?
If you did name equals self.name.
Oh, okay.
Yeah.